Good morning. This is Roji, and I'll explain some aspects of depth first search in this session. Already in the last session, we saw the basic aspects of depth first search, the differences between depth first search and the breadth first search, and the format which has been used in the both. In this session, we'll see some examples of depth first search. For this, I have taken a graph which has nodes A, B, C, D, E, F, G, H, and S. Something I want to specify. If they specify that something is the source node, you have to go by that. But in this case, nothing has been specified, so there is no wrong in taking A as the source node and E as the target node. Right? If it is specified, you have to go by that. Since it is not specified, we will follow this approach. And another thing I want to mention is, in some problems, they will give a function called moveGen. This moveGen will tell you which are the neighbors of a particular node. If not specified, you can follow the alphabetical order for selecting the nodes. Okay, so since no moveGen has been given, I'll follow the alphabetical order, right? And I'm taking A as the source node and E as the target node. So for this, we will have two lists, open and closed. And depth first search has a stack like structure. Okay, has a stack like structure, and you will go from A, you will go through one path completely till you reach the target. Whereas in the case of breadth first search, it's not the case. All these things were explained in the previous session. So to do this depth first search, I have taken two lists which are called the open list and the closed list, right? So I have taken A as the source node. Initially, we will assume that both the lists are empty, right? I'll start with the first node A, right? And the closed list is empty. Now, this element is transferred to the closed list, right? And I'll check what are the neighbors of A. The neighbors of A are B and C. Am I right? So I'll take them and I'll put them in the open list. When I put them in the open list, remember, I will put them in the left side, BS. Okay. Now the node which is in the left side is shifted to the closed list. Okay. So B I am taking. To maintain uniformity, I'll put the element in the left side. I'll add the elements in the left side in the closed list also, B comma A. Okay, now here I should add the element of B. When I add an element of B, when I add an element of a particular node, I should make sure that it is neither in the open list nor the closed list. So when I take B here, what are the neighbors of B? The neighbor of B is A. So I can't do anything with that because A is already in my closed list. So I'm not going to do anything here. I will do it. So when the next step comes, what should I do? S should be transferred to the closed list. S comma B comma A. Okay. And now what are the neighbors of S? Neighbors of S are C and G. How do I add them? As I said, I'll add them in the alphabetical order. Okay. So C comma G. Now as usual, the node which is in the left side is shifted here, C comma S comma B comma A. Okay. And here I'll add the neighbors of C. What are the neighbors of C? The neighbors of C are F, the neighbors are, it is neither in the open list nor the closed list, D, S and G. Out of this, I need not add S and G because S is in the closed list and G is in the open list. So which are the things that I have to add? I should add D, E, F, right? Already I have a G over there. So I'll add that in the alphabetical order. D, comma, E, comma, F, comma, G. Right? Now as before, I'll shift the leftmost element to the closed list. D, comma, C, comma, S, comma, B, comma, A. Okay. Now D. What are the neighbors to the graph? The neighbors of D are C. It is in the open list. So I cannot add anything. I'll add the list as such. E, comma, F, comma, G. Now E, the leftmost element, can be added here. E, comma, D, comma, C, comma, S, comma, B, comma, A. Okay. Now what are the neighbors of E? The neighbors of E are C, which is already added, F, which is already added. One new element, H, is there, which is not been added. So I will add H here, right? H, comma, F, comma, G. Okay. In the next step, sorry, I'll extend my line. Okay. Yeah. Sorry about that. Yeah. Okay. Okay, yeah. Now, what are the neighbors of H? Neighbors of H are G, E. Everything is already added. So, I don't have anything else to add. So, I'll retain the list as such. It will be F, comma, G. Whereas, I should have done something first. H should have been shifted to the closed list. Never forget to do that first. H, comma, E, comma, D, comma, C, comma, S, comma, B, comma, A. Okay. Now comes F next. F is the leftmost element. What are the neighbors of F? The neighbors of F are C is already added, G is already added. Yeah, only C and G, so nothing I have to do now, right? So I'll simply add F here. So my list becomes F, comma, H, comma, E, comma, D, comma, C, comma, S, comma, B, comma, A. Okay. And my open list has only G now, right? G is the last node, right? G, I can't do anything here. G, I'll just add it as such. So my complete list becomes G, comma, F, comma, H, comma, E, comma, D, comma, C, comma, S, comma, B, comma, A. Now, in this, okay, I have done the search of the complete graph. Okay, but what do I want? I want a path from A to E. Is that clear? Since I had completely done this, since I wanted you to have an understanding, right? So if it is the case, where do I start my process? I can start my process, I can stop my process as soon as I reach E here. Am I right? So here, this is the junction where E has been reached. This is I can stop the process here. Okay. So I will write it for the examination also. If they have clearly specified the source and the target, you can stop your process when the target element enters the closed list. And these two steps I gave them just for your understanding. Okay. So these three steps I gave them just for your understanding. Okay. Now, yeah. So here, what do I write now? The path from A to E. The path from A to E is what? The path from A to E is, come on, A, comma, here. I'm doing this step. A, comma, B, comma, S, comma, C, comma, D, comma, E. Right? So can we have a look at the graph? A, B, S, C, D, E. Okay. Yeah. Yeah. A, B, S, C, C, D, E. Look, it goes from A to B, right? It goes from A to B, and then it cannot proceed further. So it comes back to A, S, C, D. Again, you cannot proceed further. It comes back to C, and then goes to E. So it follows a depth path. It doesn't. For example, for your clear understanding, A has B and C, B and S, they are at the same level, am I right? But my graph doesn't do that. I go to B, and then since I cannot go further, it comes back to A, and then it follows S, C, D. It stops here. D is not my end. I have to go up to E. So it comes back to C and it goes to E. So this is how the depth first algorithm operates, right? And this is my path. So I hope you understood that. The next session will be on breadth first search. I'll do some problem, and after that we'll combine breadth first and depth first